All right, group, we are on example 2 of our lesson 3 notes. Okay, so it says here, a ball is thrown in the air. The path of the ball is represented by the equation. It says include units. It says graph the equation over the interval from 0 to 8 on the accompanying grid. Well, how are we going to do that? Absolutely, we're going to use Desmos. I hope that that's what you were thinking. Okay, so here's my Desmos. Now, when we put this in, we want to make sure it's in y and x variables. Okay, so I'm going to change that over to y and x. I'm not going to really worry about plugging in the y. I'm just going to worry about x. Oops. So what? Negative x squared plus 8x. Okay, you can see the graph, obviously, but we really want a table so that we can graph from 0 to 8 and do it the proper way. So you're going to hit this wheel over here and then the table, and it'll create a table for you, which is really awesome. Okay, so we want to graph from 0 to 8. So I'm going to add in some numbers here. 4, 5, 6, 7, 8. Okay, awesome, awesome, awesome. All right, so we have our table. Let's go ahead and plot some points. So 0, 0 is our first one. 1, 7 is our second. 2, 12. 3, 15. 4, 16. 5, 15. 6, 12. Almost there. 7, 7. And 8, 0. Okay, so you should see your graph there. I'm going to just roughly draw my line to connect all my points. It's not going to be beautiful, but that's all right. Make it look as good as we can. All right. All right, part B. What is the maximum height of the ball? So if you look at what's labeled, down here we have the time in seconds. Here we have our height in meters. So up here is going to be our highest height, which was 16 meters. Okay, then it says here, how long is the ball above 7 meters? So right here is at 7 meters, so you can go ahead and draw a line straight across there. Okay, so from time of 1 all the way until the time of 7, from 1 to 7, the ball is above 7 meters, right up here. Okay, so if we do 7 minus 1, that's a total of 6 seconds. Okay, I'll put a little in parentheses, we did 7 minus 1 there. Okay, part D, when is the ball increasing? When is it going up? Okay, well obviously from here to here that ball is going up, right? Think about the line, think about slope. If we were to connect these two, that would be increasing, that would be going up. So from time 0 to time 4, that ball is increasing. So we'd actually kind of write this like a domain. We'd say x from 0 to 4 is where it's increasing. Okay, actually, you know what, guys? I'm so sorry. Please erase those equal to's. We're not going to use equal to's on those because technically at time 4 it's not increasing. It stopped at time 4. Okay, decreasing. Decreasing from 4 until 8, right? And again, we're not going to put equal to's on those because, again, right here is the ball kind of stopped and then it went back down. Okay, our domain is the list of all x values. Our range is the list of all y values. So if you look at all of our x values that are used, they range from 0 to 8. We will put equal to's on those because they are included in our graph. The range okay, is from 0 all the way up to 16. 0 to 16. And remember, when you do the range, these are y values, so make sure you use the variable y.